Hello friends, this is Praveen and today we are going to learn about the three-dimensional shapes. So first, we know about the shapes. There are many kinds of shapes just like circle, square, rectangle, triangle, pentagon, hexagon, etc. So what is 3D? That is three-dimensional. So we know that to be anything we can see or feel, it must have length, breadth and height. So, if an object has all of these, then it is said to be 3D. That is three dimension. If it has only length and breadth, it is said to be 2D. And if it has only the length, it is said to be 1D. Or if it has none of these, it is said to be 0D. That is zero dimension. So, these are the three. What is 3D? But what does it mean when these 3D and shapes come together? For this, let's go to basics. So first, what exactly is a how we can obtain these figures? So first, we know if I have to locate any point that is a place, I use a fixed dot. This fixed dot in math is known as point. For this point, you can neither measure the length, breadth or either height. So it is 0D. So that is stand for zero dimension. So now let's take 2 points and a point A starts going to the point B. But each step it takes, you started locating its distance. So it appears as if there is dot. So when A will reach the B and it would seems it is going in a straight line. So this line is referred to as 1D. Because if you would stand up on this line, you could only move in one direction or either in this direction. That is only one direction. So only we have length to measure it. So now what happens? Instead, now if I will take many lines in the horizontal place, it would not create any difference. It would make the line longer. Now instead of taking this line horizontal, I started stacking up in the vertical column. So what do I get? I get a plane. So this is known as a plane. So what it is two dimension, because now if you would stand up on top, you would go either in this direction or either in this direction, or you can either go in this direction or either in this direction. So the two things can be measured in this, so it is known as 2D. So two dimensions. So now let's move to the 3D. So if I will take this plane and add up in this direction, that is the vertical direction, it would create no difference as well as in the horizontal direction. So what I do, I started stacking up these, that is planes. So when I will stack up these planes many more, I get a solid shape. Solid shape. So now we know that we can measure the length, breadth as well as its height. So it is three-dimensional shape. And if you would stand up on this, you could measure the length, where you could move through the length, breadth as well as the height. So friends, you may have noticed that I use the word solid. So what does the solid means? The solid in math means it has the mass and occupies its space. If an object has mass and occupies its space, it is known as solids. Example of this pen. This pen is solid. I can hold it, it occupies the space and it has mass. So it is referred to as the solids. Now we have made these solid shapes with the help of the points, lines and these 2D shapes. So it must contain all of this, but it contains in the different forms. These are known as the components of the solids. There are major three components of the solids, that are faces, edges and the vertices. So first let me create a shape in which the points that you can see or the corners is referred to as the vertices. So it is made up of a point, so it is only one dimensional. That is, the point has zero dimension, so it is 0D. And now the line that you can see here, these forms up the edges. So the edges is made from the line, so it is one dimensional. And then you can see this the rectangular shape present here, it is known as face. So face is the 2D object. So these are the components of the solid shapes. So what is 0D? Edges is 1D, that is made from the lines, and the faces is 3D, that is 2D. So how we can know where is the vertex, where is the edge and where is the face? So first, when you will draw this diagram, all the different lines you can make is known as the edges. So here in the case, this I make a line. This is known as the edge. So edge is the meeting points of the two or more faces. That means there are two faces. So I am joining this. This forms the edge. So what is the faces? Faces is the enclosed shape made by the edges. So if I had four edges, I got up the quadrilateral. If I have three triangle, five, that is I got a pentagon, and so on. In fact, circle which is made of the infinity points is also the shape, and this line which I have made is known as the edge. And what is the vertex? The vertex is where the two or more edges meet. So a point where here you can see the three edges meet, which is one this, two this, and three edges are meeting at this point. So this point is known as the vertices. So now we have understand what is the components of the solid shapes. So we for the 2D shapes, we know there are many kinds, just like rectangle, circle, pentagon, triangle, hexagon, etc. So are there various kinds of 3D shapes or solids? Yes, well there are. So first one is a cube. So we know about this square. It has all, that is the length as well as the breadth same, so we can rewrite it as both as AA. AA. So now what if I do, I stack up these squares many times until I get the height also as A. So I get this height also as A, until I get this height also as A. So what do I get this? This is known as a cube. Cube. So let's see how many components are present in the cube. So if I get this a cube, and let me name these points as A, B, C, D. Let me name this point as, now these are three points. Let's name this point as E, F, G and H. So how many vertices can you see? Because I have named these as points, so we know that the number of points is known as vertices. So I have that is vertices as A, B, C, D, E, F, G and H. So there are total, we can replace this with 8 vertices. Now how much edges is have? Edges are the lines. We can simply first let's calculate the lower one, that is AB is one line, then we have is BC, this line, then we have is CD, which is this line, and then we have is DA. So these are the lines or the edges which are at the lower level. So in this layer, that is the middle layer, we have is A, E, B, H, then we have is D, F, and we have is C, G. So total we have is in this middle part we have is 4 edges, and on the top we have is EH, then we have is HG, then we have is GF, and we have is FE. So these are the edges. So how much total edges we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 4 in the lower part, 4 in the middle part, and the 4 on the upper part, that is 4 3s are 12. So a cube has 12 edges. Now how many faces it have? So faces, the first face, that is the lower face, that is the bottom face, that is A, B, C, D, that is the lower face. Let's move to the front face and the back face, that is B. Then we have is after B, C, G, H, that is the front face, and the back face is that A, E, F, D, that is the front face. So let's move to the top face, which is E, H, F, E, H, G, F. This is the top face. Now we have been remaining with the two faces, that is on the either side of this face, that is E, A, B, H, and on here we have is D, C, G, F. So these are the faces. We have total 6 faces, that is 2 lower, 2 front and back, then 2 on the sides. So a cube has total 6 faces. So these are the properties of the cubes. So in fact of stacking this square, if I stack up with random that is length, breadth and the height, so what do I get? I get up the cuboid. So what is a cuboid? A cuboid is a solid shape which is obtained by stacking up the rectangles which could have any height. So if this is a rectangle, that is cuboid, let's name this as A, B, C and D, and let's name this E, F, G and H. So edges would be the same points, so we can, that is vertices are the points, so we can write as vertices is equals to 8. That is 4 on the lower, 4 on the top. Now if we will count the number of the edges, so we get edges, which is the number of lines, so we can get 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the middle lane, and the 1, 2, 3, 4 on the bottom lane, that is equals to 12. So how much faces it have? It have it has the faces is equals to 2 on the top, that is 1 on the top, 1 on the bottom, 1 on the side and 1 on another side, 1 in the front and 1 in the back. So it has total 6 faces as the cube. Now I can take any shapes on the bottom and I can create any solid shape, and by stacking up this. So what is this stacking up? So the figures which are made from the stacking up of the things are known as the prisms. So what happens in a prism, if you will take a square also and stack up, we got up the square prism, which is for this abstraction case we know it as a cube. If we will take up the rectangle, it is known as a cuboid. But naming all of these just like triangle, pentagon, hexagon would be very lengthy. So what we do is we take these shapes and we have this pentagon here. So we take the shapes and we add prism to it. So it is triangular prism, this is square prism, this is rectangular prism, and this is pentagonal prism. So we can conclude that the cube and the cuboid are the types of the prisms. So let's see how many, what are the number of edges, vertices, and the faces present in the prisms. Let's so if we have the n number of the, if we have a polygon that is a regular polygon with a, or any polygon with a n number of sides, we can calculate the face, because so now if we have the scenario in which we know that the 5 sides which has making would have each its face, and one on the top and one on the below. The number of, so here face would be is equals to the number that is n, because it has its own side, plus the 2 that is the face that is on the top and the top that is below. So if we will take the edges, so how much edges it have? It will have the 5, we know that is stack up. So the bottom shape and the lower shape would have the same number of vertices, that is the number of the sides it have, and each side would have its own that is edges, which is in this case 1, 2, 3, 4, 5. So it would be 3n. It is 3 times, because in the middle lane, in the top lane, and in the bottom lane. So how much vertices it has? So it has it would create a vertices that is meeting point of the top face and the that is the side faces, because the bottom face can't meet. So it would meet at the number of the sides it have. So it would have been the number of vertices would be in the first lane, if it is n number of sides, it would be n, and in the lower lane it would be again plus n. So we get that is n plus n, that is 2n. So if any regular, that is any prisms is given, we can find the number of faces, edges, and vertices by this formula. So now what we have, now instead of taking up the stacking up the shapes, we can either take something that is a shape on the below and stack up, or create an unclosed that is closed figure by overlapping triangles. So I get these types are known as the pyramids. As you see in the pyramid of Giza, it has a square bottom face, and all its side another faces are triangles. So you can take any base for the inspection case. If we have a triangle at the lower case, this type of the figure is known as tetrahedron. And if we take this square, then it's known as square pyramid, and pentagon is for the pentagonal pyramid, and so on. So let's focus on this. So how much faces it have? It have the lower face, that is the shape initially it have, and the number of sides would be that the number of the squares it has to create an enclosed figure. So it we can take the faces as if it has n number of the sides, the polygon which is at the base, so it would have n, which is the lower face, plus which would be the number of the triangles it have. So it has n plus n, which is equals to 2n. So it has 2n faces. How much edges it have? It has the same edge as it of the side it contains, and the squares would have also the same. They would also share these same faces. So the number of edges would be also 2n. Now, how much vertices they have? Because we know that one on the where the triangles are converging is one vertex, plus the where the number of sides it have is the all these vertices. That means the number of vertices equals to n plus 1. So it works for the all of the pyramids. So if you would take the case of a tetrahedron, so if I have a triangle as a base and I create the tetrahedron, so what would be in this case? The number of faces would be, that is, and let's take the n value as the n as 3, and the number of face would be 3, that is 3 plus 1, that is 3, and plus 1, that is equals to the number of, that is 4. So it has the one lower face and the 3 top face. Now the number of, that is vertices is edges is 2n. That means n is 3 and the number of vertices would be 2, and that is 6 vertices. Then 3 on top lane and the 3 on the lower lane. So we have 6 vertices, that is edges. So number of vertices we have no, that is as 1, 2, 3 and 4 vertices. So if we will take value of 3 as n, 3 plus 1, that is 3 plus 1, which is equals to 4. So it has 4 vertices. So now let's take the abstraction cases where we have this circular at the creating of these both prisms and the pyramids. So what if we take up the circles and stack up many circles? What do we get? We get up the cylinder. In the cylinder, the number of faces is the 2 circular faces and the 1 curved faces, so it has 3 faces, and number of edges would be 1 at the lower face and 1 on the top face. But this is not a edge, because the it is only a single consecutive shape which is a rectangle, so it doesn't have any edge, so it has only 2 edges. And the number of vertices, so it has no vertices because nowhere the edges are meeting, because there are 2 separate edges. So it has that is vertex is equals to vertices equals to 0. So this is the case of the cylinder. Now let's take it for the that is a circle for the pyramid. For the circle for the pyramid, if you will take the circle, because circle has infinity sides, we must take the infinite triangles to form up the cone. So this infinite would take only a form up of one curved sheet on the top and the one. So number of faces of the cone would be the one on the bottom, that would be 1, and the one that is a curved face, so it has 2. Number of edges is only 1 where the circle is, so 1, and the number of vertices is on the verge where all the triangles, that is infinite triangles, are converging, so it has 1. Now we can create another. Now we have seen a ball. A ball can be neither created by the prisms or the pyramids, or we can say it can be created by both. So what? How can you create a sphere? If you will take a small circle and stack up the larger circle, and larger circle, and then you repeat this action which is inversely. So we get up a sphere, or you can take a circle and along this axis you can rotate it 360 degree to get up a sphere. So it is getting by both of these methods, or you can see none of these methods. So if you will take the sphere, how much faces it has? It has only the one curved face, which you can see if you will rotate, it would be only the part of the curved faces. So it has one face. The number of edges, so it has no edges because nowhere the face is meeting, only it has one face. So it has 0 edges and So if there is no edges, then there is no vertices. So this is what a sphere has. So now we are going to move to the Euler's formula. What is the Euler's formula? States, let's see with an example. We know that if we have a cube, the number of faces would be 6, number of edges would be 12, and the number of vertices would be 8. So we can, for the rest of the figures, we can see and check that the number of faces and the number of vertices is one more than the number of the edges. So we can write it as like that is faces plus vertices that is equals to edges plus 2, because then it would be 6 plus 8 is equals to 12 plus 2, that is equals to, here we have 14 plus 14. That is 14 is equals to 14. So this is known as a Euler's formula. It works for all the polyhedrons. So we have talked about what are solids. The solids which have mass and occupies the space. But the mass depends upon the what kind of material it is made up of. But that can be vary in the mass. So there are two fixed quantities in the mass for the solid shapes. That is the surface area and the volume. What is the surface area? The surface, if we take up the object and you have to cover it with the paper, what is the minimum length of the paper required to cover the solid shape, and the volume is how much water you can fit, what is the maximum number of the water molecules which would fit in that, or what water can fit in that. So in this grade, we are only going to learn about the surface area and the volumes of the cube, cuboid, and the cylinder. So, if we have is a cuboid, so we know that it has the A here, and the A here. So, number of the then what is the surface area? We can calculate it as a total surface area, that is TSA. We know that one surface area would be A square, and there are total 6 faces, which is all are identical. So we can multiply by 6, so we get this as 6A square. So if it only asking about the lateral surface area, that is LSA, that means only the bottom and the top parts are not included. That means we have to minus that is 6A square minus 4. We have that is 1 2. That means 2A square. That would remain is 4A square. So we have is the lateral surface area is 4A square, or you can calculate this as one area is that is A square one face area, and we require of the 4, so that we have is 4A square. So now one more important question which is asked in competitive examinations is what is the maximum number, or that is the maximum length of the diagonal of this cube. So how could you calculate the maximum? Because we know we have only learned to calculate the only the 2D shapes diagonal. But now we know that the diagonal of this would be not the longest. The diagonal from this edge to the opposite this vertex to the opposite vertex would be the longest diagonal. So how we could calculate the formula for the we know that this is that A square we can create, and then we have A square, then we have to under root this, so we get as under root 3A. So this is for the diagonal, or the longest diagonal of the cube. So this is for this that is surface area. Now what if volume is asked? We know the number of unit cubes can be fit in that is equals to A, that is A into A, that would be surface area, that means 1 6 cubes area. Then we have to multiply with A to get the total that is volume of that would be A cube. So this would be the that is A cube is the total volume of the square with that is a cube with the side A. Now let's move to the cuboid. So for a cuboid, if we have is here is length, breadth, and the height. So for the total surface area, we know that this side would be L plus B, which is the front side, and so the back side would be also congruent. That means it has to be plus L plus, that is sorry, here is multiplication, L multiplied by B. For the sidewards faces, we have is the H into B plus H into B, and for the we have calculated front. So for the top, we have is uh, H into L plus H into L. We know that all the terms are repeating twice, so we can write it in the twice L, that is bracket L into B plus B into H plus H into L. So this is the total surface area of the cube, that is the cuboid. Now if it is asked for the lateral surface area, that means we have to not include that is the L into H for both sides, so we can remove L, that is L into H, and this is the total lateral surface area of the cuboid, that is 2 L into B plus B into H. So what would the cuboid for the diagonal of the longest diagonal which could fit in the cuboid, it would be the under root L square plus B square plus H square. So this would be the longest diagonal which would fit in this cuboid, that is cuboid. Now what is the total volume of this cuboid? So the total volume of this cuboid is, we know that length into breadth will give a surface area, and that much times of the square, that to create a cube we have to record with multiply with height. So we can write the total volume of this surface as L into B into H. And so if it has all the same units, just like if it has meter, so the unit would be meter cube, because it is multiplying by getting multiplied by itself by 3 times. So this is. Now we have is a cylinder. How we can measure the surface area and volume for the cylinder? The cylinder may be vary, because we can have a cylinder which is not perpendicular. But in this chapter, we are only going to discuss about the right. That means it is right from the base. So right circular, because now its face would be elliptical. But now in this case, we will take the base and the top only as a circle. So we can say it is right circular cylinder. So if it has the that is radius as R and height as H. So what would be the surface area of this? The surface area would be first we have to find out the area of the top face, that is 2 that is top face is pi R square, and multiplying by two sides, that is for top and below, that means times 2. And now to find out the surface area of the this rectangle, we have to take the now we know it is R, so we can find out the circumference of this area. So that is 2 pi R multiplied by H. So we have it, this is 2 pi R H. So here this is the area for the top and the circular face, and this is the area for this rectangle circle. So if it is only asking for the that is lateral surface area, then it would be 2 pi R. So it is lateral surface area. And this total, if you will take it together, it would be the total surface area. So this is the total surface area and the lateral surface area. So what is the volume of this? So volume is classified as the 3D quantity. So if you have is, take this radius of this and convert into the area. To convert into area, we got 2D. That is A is equals to 2D. To create it 3D, we have to multiply it with height. That is 3D. So now we have get this. So we can find this the 2 pi r, that is for the area of this is 2 pi r square, and to multiply with it with height, we get of this as the volume. So the volume of this cylinder is the volume, that is h pi square, that is the volume of the cylinder. So this is all in this chapter. So let's summarize what we have learned today. So first we started learning about what are the 3D shapes and what are the solid shapes. And then we learned about the solids. What are the definitions of solids? What are the components of solids? That is faces, edges and the vertices. The faces is referred to as the 2D, the edges is referred to as 1D, and the vertices is referred to as 0D. Then we learned about the cuboid, which are both in fact the part of the prisms. And prisms and the another quantity which is that is pyramids, and we learned about the cone, cylinder and the sphere. And then we learned about the Euler's formula, and then we learned about how we can calculate the surface area and the volume, and what exactly is the surface area and the volume. So we learned about the cubes, the surface area, lateral surface area and the volume of the cube, and the cuboid, that is the surface area, lateral surface area and the volume for the cuboid, and as well as the right circular cylinder. So friends, I hope that this chapter is clear to you, and at the last, thanks for watching.